Good afternoon, student. In this lecture, I will discuss about the overall heat transfer coefficient. What is the meaning of overall heat transfer coefficient? You, in last PPT, I discussed about there are three methods of heat transfer. First is the conduction, second is the convection, and one method is also involved, that is the radiation method. But in this PPT, we will discuss about the overall heat transfer coefficient. Means here we will be including the method which will also have the conduction as well as the convection. Now just go to the first slide. What I have written here, I have written in many heating or cooling application, conductive and convective heat transfer may occur simultaneously. So it is written there are so many operations in which the conduction as well as the convection, both of these process occur at the same time. I will discuss about this. I will discuss one of the example. This derivation is all about that example only. So here this example is given. What is that example? That heat transfer in a pipe that carries a fluid at a temperature greater than the temperature of the environment surrounding the outside of the pipe. So here one example is given. You have to consider a pipe, metallic pipe you can take, and any fluid is flowing inside that pipe. You may consider like water is flowing, and the temperature of the water is higher than the outside temperature, the temperature which is present in environment or which is present outside the pipe. So this thing is given here. Heat transfer in a pipe that carries a fluid at a temperature greater than the temperature of environment surrounding the outside of the pipe. In this case, heat must be transferred from inside fluid by forced convection to the inside surface of the pipe, and then by conduction through the pipe wall material, and finally by free convection from the outer pipe surface to the surrounding environment. What actually happening here? Here both the heat transfer method are involved. Now how the heat transfer is occurring? You can see this graph here, which is representing that temperature and distance from the center. So what actually this is defining? It is defining that when fluid, example I take that water is present inside the pipe. So what is happening here? Water will be transferring some amount of heat to that metal. So how the transfer will occur? Water, it is a fluid. So which method is involved? The convection method is involved. Through the convection method, water is transferring heat to the metal, inside surface of the metal. Now there is a certain thickness of that metal. You may assume like 5 centimeter or 10 centimeter. So now heat will be conducted from inside surface of the metal to the outside surface. Now this metal is present in the solid form. So heat will be conducted through the conduction. Now again further, now heat has been reached at the outer surface of the pipe, and now it is in contact with the air of the surrounding. So heat transfer will occur here through the convection method. So in this process, two convection and one conduction is occurring. It is written here. Now you can read again it. Like in this case, heat must first transfer from inside fluid by forced convection to the inside surface of the pipe. So firstly heat is transferring from water to the inside surface of the pipe. Now then by conduction through the pipe wall material. After that it will conducted through the conduction method inside the metal. Example you took, like if the 10 centimeter is the thickness, so into this 10 centimeter the heat will be conducted by the conduction method, and then by conduction through the pipe wall material, and finally free convection from the outer pipe surface to the surrounding environment. After that the convection method is involved from outer pipe surface to the environment. Thus heat transfer is through three layers in a series, and using the approach of thermal resistance value we can write. Now on the basis of that we have derived this expression. So what is that? Firstly Q equals to T minus T infinity upon RT. So here Ti, it is the temperature which is present inside the pipe. T infinity, that T infinity is the temperature which is present outside the pipe, and upon RT, where RT is a combination of thermal resistance in the inside convective layer, the conductive layer, and the outside convective layer. RT is basically the resistance, and this resistance involves three resistance. What three resistance are involved here? Firstly, when the convection is occurring, where the convection was occurring, it was occurring from hot water to the metal. After that, conduction is occurring from inside metal surface to the outside metal surface, and finally the convection is occurring from outside metal surface to the surrounding. So here three process is occurring. So this RT, it is the sum of RT inside convection plus RT conduction plus RT outside convection. After that, this is a formula, that is RT for inside convection. When we are considering the convection process, then this is the formula for determining the resistance, that is 1 upon Hi or and Ai. So what is Hi here? Hi is the inside convective heat transfer coefficient, and Ai is the inside surface area of the pipe. This inside convection method, it will be depending upon two factors. One is the convective heat transfer coefficient, and Ai is the internal surface area. After that, again the resistance of heat transfer in the pipe wall in. Now this RT for the conduction. I told you that conduction is occurring inside the metal surface. So this is the formula for that, that is the natural log R naught upon Ri divided by 2 pi KL. Now what is the meaning of this R naught and Ri? It is defining here, like K, it is the thermal conductivity of the pipe material. T, Ri is the inside radius, m is basically the unit in the meter, and R naught is the outside radius of the metal. Now resistance to heat transfer due to the convection at the outside pipe surface. I told you about the RT inside convection, RT conduction, then one more convection is occurring, that is the outside convection. So again it will be depending upon two factor, that is 1 upon H naught A naught. H naught is the coefficient of heat transfer coefficient, and A naught is the outer area of the pipe. Now what I have done here, I have placed all the value, that Q equals to, above I define one equation, Q equals to T1 minus T naught upon RT. So now RT has been defined here. RT is equals to the R inside convection plus R conduction plus R outside convection. So all these values has been placed in this equation. So Q is equals to T1 Ti minus T infinity upon all these values, sum of all these value. After that, we can also write an expression for overall heat transfer coefficient. This is one of the example. This is also a method through which we can explain the overall heat transfer coefficient, that is Q equals to Ui Ai into Ti minus T infinity. So where Ai, it is the inside area of the pipe, and Ui, it is the overall heat transfer coefficient based upon the inside area of the pipe. So now if we compare both of these equations, that is 4.81 and 4.82, so what they have done, we can also write this equation, that 4.82 Q upon 1 upon UiAi, because it is the same thing. If you will transfer it above, it is the same thing here. So now what we have done, we have compared the equation 4.81 and 4.83. So on the basis of this equation, 1 upon UiAi is equals to 1 upon HiAi plus these all resistance of inside convection, conduction, and the outside convection. So this is the calculation of the overall heat transfer coefficient.